So today we're going to continue with the radioactivity series, and in the last video we looked at the gold foil experiment, and from this we were able to determine that the atom has a small positive nucleus. Today we're going to look inside the nucleus and see what makes up the atom in more detail. So the atom is made up from three particles: the proton, the neutron and the electron. The proton and the neutron are the particles which make up the nucleus, so we call these two particles nucleons. Then we have the electrons, which we've came across before. These electrons orbit the nucleus in energy levels. Because all these particles are smaller than the atom, we can refer to them as subatomic particles. The properties of these particles are as follows. The protons are found in the nucleus. They have a relative charge of +1 and a relative mass of 1. The neutrons are also found in the nucleus. They have no charge and a relative mass of 1. And the electrons are found in energy levels which orbit the nucleus. They have a relative charge of -1 and a relative mass of 1/1840, which is approximately 0.0005. And because this mass is so small compared to the proton and neutron, we can say it's negligible. To find the number of protons and neutrons of each element, we need to look at the periodic table. Each element on the table is associated with two numbers, so let's look at carbon for an example. If we look up carbon on the periodic table, we see it has the numbers 12 and 6 associated with it. So the bigger number is the mass number. This is the number of protons and neutrons in the atom. And the smaller number is the atomic number. This tells us the number of protons in the atom. So the atomic number of carbon is 6. This means that an atom of carbon will have 6 protons. The mass number of carbon is 12, so the total number of protons and neutrons is 12. Now we can use these numbers to find the number of neutrons. All we have to do is take 6 away from 12, so an atom of carbon contains 6 neutrons. Now each element will always have the same number of protons, but they can have different numbers of neutrons, and we call these isotopes of an element. For example, let's look at hydrogen. It can exist as hydrogen 1, but we'll just say hydrogen, or it can exist as hydrogen 2, which is called deuterium, or hydrogen 3, which is called tritium. Notice that the number of protons stay the same, and if it was changed, then it would no longer be a hydrogen atom. But the number of neutrons has changed, and this is allowed, so we define these as isotopes. These are elements with the same number of protons but a different number of neutrons.